So far in basketball season, during games, Charlie has shot 30 free throws. Unfortunately, she's made only 13. Up to this point, what is her stat for percent of free throws made? 13 over 30. Somebody tell me the decimal equivalent of that, please. .433. Well, let's just go to 3 today. We'll be okay with 3 today, for the most part. Okay? After such a poor start, Charlie gets some advice from the coaches and practices daily. If she does not miss another free throw for the remainder of the basketball season, how many consecutive free throws will she need to make before her percentage reaches 80%, 90%, 100%? So let's work on this. Let's gather some data. Okay? So right now she is 13 for 30, correct? If she makes the next free throw, and we're planning on her making all of the ones from now on, okay? If she makes the next free throw, she would then be 14 for 31, correct? What if she makes the next one? What would she be then? 15 for 32, and then 3, and then 4, 17 for 34, 5, 18 for 35. That's a weird one. What about 10? Now, how did you do that? Did you go back to the original one? Could you? Yeah, you could, right? What would you do if you went back to the original? Add 10 to both? Okay. So 23 out of, 40. What about 20? So you could add 20 to the beginning, or you could just add 10 more to these, right? Okay, that's good. 33 over 50? What about 50? 63 over 80? And what about 100? 113 out of 130. Ooh, what about X? Is he right? Did you have a chance to think about it? No. Okay. Is he right, though? X plus 13 over X plus 30? Because like we talked about from the beginning, we could just add to the previous one, but if I got struggling with the math, I could just go to the beginning and add the number that she had made, right? So does this make sense? Okay, so here's what we're going to do. So this can go faster. Andy, we're going to start with you. Andy, I need you to do the decimal of this fraction. Kent, would you do 1? Paige, would you do 2? Emily, would you do 3? Avery, 4? Alyssa, 5? Tanner, 10? Chandy, 20? Seth, 50? Wyatt, 100. Sorry, my nose is running. Okay, right now. 0.433. Okay, 1? 0.45 exactly. Give me one more. 2. Okay, 2. 468. 3. 484. 4. Exactly. Okay. 5. 514. 10. 20. Repeating. So like that. Exactly 0.66. Okay. 50. And 100. Okay. So now, Andy, I'm going back to you. Tell me mathematically what's happening when we go from a decimal to a percent. Mathematically, what's happening? Do you know? By what? Multiplying it by 100. Okay? Physically, what do a lot of people think to do? Move the decimal, right? And as long as you realize you're multiplying by 100, I guess I'm okay with that. Okay? Andy, tell me your percent. 43.3. 1. 45.2. 2. Whoops. 3. 4. 5. 10. 20. 50. And 100. Now, I know that it says percent at the top of the column, but the answers would be more accurate if, yeah, percent, percent, percent. Sketch the graph of this relationship in the given window. So notice that the x-axis starts at 0 and goes to 110. The y-axis actually starts at 40. God bless you, and goes up to 110. Okay, so be careful when plotting your points. Some of these are going to be hard because 1, like really? Because that's all of the ones that I have to fit these in, right? So just get something on there carefully. 43, 45, 46, 48, 4 is 50, 10 is 57, 20 is 66, 50 is 78, 100 is 87. Maybe like right there. Does yours look similar to mine? So something like that. Okay so far? What equation relates these two quantities? Y equals what? We already figured it out, didn't we? When we filled out our column with their fraction? Isn't it right here? Absolutely. X plus 13 over X plus 30. Now, these three questions at the bottom, I would like to ask them, and then I would like at least 5 seconds of thinking time before anyone says the answer. Is that fair? At least 5 seconds of thinking time before anyone says the answer. After how many consecutive free throws will Charlie's percentage reach 80? Anybody have any guesses? So are you guessing? Okay, is there a way we could know? So I just put it in my calculator. I'm scrolling. Control T. It would help if I had the right equation in my calculator, wouldn't it? X plus 13 over X plus 30. Control T. What am I looking for in the Y column? 0.8, right? 0.8 for the decimal. Oh, I missed it. $55. When will the percentage reach 90? What am I looking for? Okay. I'm glad to see most of you doing this on your own instead of just waiting till I find it. Thank you. 140. I plugged in the equation right here and then just went and looked at the table, looking in the y value and the decimal value for first 0.8 and then 0.9. When will it reach 100%? 5 seconds of thinking time is what I requested. Am I correct? So say it again, because nobody had a chance to think about it. When will it reach 100? Why? Why is it never? She already missed some, right? She missed some in the very beginning. She only started making out 13 over 30. So if she already missed some, can she ever get to 100%? No. Okay? I would really appreciate you respecting waiting time. Okay? That's been an issue in the past and it's become an issue again. I need you to respect waiting time, especially when I specifically ask for it. So I wrote never. I want you to write a sentence about why. I'll write a sentence in a moment. I want you to have a chance to each write your own sentence. Also a sentence form, capital, punctuation, all that kind of stuff. What did you write as your sentence, Emily? That's an excellent sentence. Here's mine. That's almost exactly the same that you wrote, isn't it? Good. Did you write something similar? Check each other's paper. Check each other's paper, not just for content, but for capitalization, punctuation. Okay? Often when using rational functions, when you plug in larger and larger numbers for x, the answers for y keep getting closer and closer to a certain value. That value is called a limit. When you get to pre-cal and calculus, Mrs. Patton is going to be very happy that we've talked about a limit. Now, we've talked about a limit on Algebra 2 level. You'll talk about limits on pre-cal and calculus level when you get there. But what is a limit? When you plug in larger and larger numbers for x, the answers for y keep getting closer and closer to a certain value. You're getting to the limit of that value. The limit is the spot that it can never reach, but we say it's approaching that, but it's never reaching, right? That's the asymptote. Okay? So, here's what we're going to do. First of all, in the basketball program, what's the limit on Charlie's percentage? What's she never going to get to? What's it approaching? 100%, right? We say her limit is 100%, knowing that it's not ever going to get there. It's just approaching 100. Got it? Graphically, this makes an asymptote. What kind? Go back over to the front. For sure. Let's draw it in. That's our asymptote right there. This part of the information is going to keep getting closer and closer to that line, right? The further out we go, but it's never going to get to 100, is it? Okay. Okay. Predict the location of this type of asymptote. Here's where we're going to gather data, see if we can find the pattern. Here's where we're doing it the really long way, so you guys don't have to do the long way, but so you can see the pattern and do the short way. Is that fair? Okay, but we've got to do all 8 of these problems so that we can make sure to get it done. Make sure to figure out that pattern. Okay? Andy, would you in your table do number 1 and number 2? Would you guys do number 3? Would you guys do number 4? Would you guys do number 5 and 6? And would you guys do 7 and 8? Okay? When you fill in your table, when you get yours done, if I gave you 2, split your table group in half, and one half do one and one half do the other. When you get it done, I need it filled in back here on my paper. Okay? Yes or no? Let me say it again. When you get your table done, you need to come back here and fill it in on the paper. Okay? Oh, can I show you something that might help? Is that okay? This one that I just had, that we were just using, when I have the graph open and I have the table open, go to Menu and Table and Edit Table Settings. If I go Menu, Table, and Edit Table Settings, this is the screen that pops up. And it's saying, where do I want it to start? Well, I want it to start at 0. And how do I want it to count? Well, I think we want it to count by 1,000, don't we? All these tables go by 1,000. Now look, they're all right there. Boom, boom, boom. Okay? Does that make it a little bit better? Okay, get this table filled in, please. All I want you to do is fill in the table. I do not want you to fill in anything else on this page, just the table. Decimals, and let's go to 3 or 4 or 5 if you need to. And if you have decimals in your table, you'll know what I mean if you need to. But I need it filled in back here, so hustle up. With the marker, please, otherwise you can't see it. That's why I always do a marker, because you can't see it otherwise. Thank you. Good job. Thank you. Good job. Come on, guys, let's go. We separated them out so we could do it a little faster. So hustle, hustle. Yeah, use my marker. Good job. Thank you. Yes, please. Yes, please. It is. It is. Good. Thank you. Good. Thank you very much. Nice job. No, it's fine. It's fine. No, that's good. Looks like I need one more. What? Just ignore them. You're doing fine. Who has 5? You guys have 5? Okay. Thank you, Kent. Thank you. All right, so let's make some observations. What do you notice? What do you wonder? What do you notice, first of all? What did you say? Some are going up, some are going down. That's an excellent observation to make. Some have negatives, right? Good. Any other observations? So what do you wonder? Nobody wonders anything? How are you going to figure out the shortcut? Okay, that's a fair wonder. That's what we want, right? We don't want to have to do this every time, do we? Okay, so then let's start making more specific observations. May I guide you? Okay. As x is getting greater and greater, what is y approaching? What is it getting closer and closer to? To 1, right? So we're going to say the limit of this is 1. It's a horizontal asymptote, which means it goes this way and crosses what axis? It is a line that's crossing the y-axis at 1. As x is getting closer and closer, as x is getting bigger and bigger, is there something that y is getting closer and closer to? What is it? 0.5. Now you said this, but I also want to write this. It will help us in a moment. But they're the same, right? Okay. As x is getting bigger and bigger, is there something that y is approaching? Right? Okay. What about 4? As x is getting larger, is there anything that y is approaching? Or is it getting infinitely large? So, nothing. As x is getting large, is there anything that y is approaching? Yeah, for sure. As x is getting infinitely large, is there something that y is approaching? 2.5. As x is getting infinitely large, is there anything that y is approaching? As x is getting bigger, is there anything that y is approaching? So then comes the all-important question. Is there a way to tell the location of the horizontal asymptote just by looking at the function? For me, personally, when I'm teaching this, the easiest one for me to show you is number 2. Where's the asymptote? Look at this one. Look at this one, right here. No, 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 no. You should absolutely not feel dumb. Does it work every time? Because, I mean, I could cover stuff up here, but there's not one. Cover stuff up here, and there's not one. Again, covering up stuff, but I don't think of 0, right? So let's not look at these real quick. Let's look at the one that's say, well, let's look at those real quick. Only those. Let's only look at those 4 real quick. What do you notice about the equations? Okay, that's a good observation. Oh wait, but look at this one. That only has one thing, right? But look. They all have the same exponent in the numerator and the denominator. Does this one? No. Does this one? Okay, so if they have the same exponent, then what? Then it works. Then we're covering up stuff. I mean, really, is that what we're doing? Covering up stuff? What are we doing mathematically? We're looking at the leading coefficient. Absolutely. So when the exponents are the same, we're looking at the leading coefficient. So what's different with these then? They don't have the same exponent. But what's the same about these two and what's the same about these two? Look at these exponents. The larger exponent is in the denominator. So when the larger exponent is in the denominator, automatically y equals 0. What about these two then? Larger exponent is in the numerator. So when the larger exponent is in the numerator, automatically, there's not one. Psst. So let's fill out your last page of notes because you figured it out and you can do your homework the quick way now. When we are looking to find horizontal asymptotes, first we look at the, what did we figure out first? What do we look at? What do we have to look at to know that these, we have to just look at the leading coefficients? What do we look at first? Exponents. First look at the exponents. Thank you. Find the greatest exponent used in the numerator and in the in each, the greatest exponent is called the, do you remember what it's called? We talked about it last semester. You have said it 3 times. I was trying to let everyone in the room have a chance to think. You are correct that you said it 3 times. If the degree of the numerator is greater, for example, number 4 and number 8, right? Like 4 and 8. Then there's no horizontal asymptote, and you write none. if they ask you specifically for horizontal asymptotes. Okay? There's no horizontal asymptote. Jump over to the other side. If the degree of the denominator is greater, for example, which ones? 5 and 7. Then automatically y equals 0, or the x-axis is the asymptote. Okay? When the denominators are the same, like 1 and 2 and 3 and 6, then we look right here. Y equals leading coefficient of the numerator divided by the leading coefficient of the denominator. So right here, leading coefficient is 1, leading coefficient is 1, 1 divided by 1, y equals 1. Here, leading coefficient is 1, leading coefficient is 2, so y equals 1 over 2. Do you see why I wrote both of these now? Okay. So you have 3 problems for homework. I want you to fill in the numerator degree, fill in the denominator degree, and compare them. What are you going to write in this box? Which one's greater? Or are they the same? And then what are you going to write in this box? Y equals something, or none, right? Y equals 0, y equals 2, or none. All right, does everybody have any questions about that? Do you feel better that you figured out the shortcut before the end of class? You didn't want to do all these with the table? And 1,000 and 2,000? No, okay, good. Are there any more questions on this?